In this video, we're going to solve a word problem involving antiderivatives and motion. It says a car is being driven at a rate of 12 meters per second when the brakes are applied. The car decelerates at a constant rate of 3 meters per second squared. How far does the car travel before it stops? So they tell us a few things that we need to write down. First of all, they do not tell us an initial distance. So we're going to assume that at 0 seconds, the initial distance is 0 feet. So that's our displacement there. And then they also tell us that the velocity at 0 is 12 meters per second. And then they tell us the acceleration is a constant rate, which if my velocity is positive, this would be negative 3 meters per second squared. Now I know if I take the derivative of displacement, I get velocity, and the derivative of velocity gives me acceleration. So I'm going to work backwards and say the antiderivative of acceleration will give me velocity, and the antiderivative of velocity gives me displacement. However, along the way, when we get to the velocity equation, if I set my velocity equation equal to 0, meaning when the car stops, I can find the time. And then I could use the time with the displacement equation to figure out how far the car travels before it stops. So let's start with A of t, which is negative 3. And let's take the derivative, which will give us the velocity equation. Antiderivative. So negative 3t to the 0 plus 1 divided by 0 plus 1 plus c. So I get v of t is equal to negative 3t plus c. Let's plug in our initial condition. So 12 would go in for v of t. And we get negative 3t, 3 times 0, plus c. So c is equal to 12. So we have v of t is equal to negative 3t plus 12. Now let's set this velocity equation equal to 0. If I set it equal to 0, I can find my time, negative 3t plus 12. Subtract 12 on each side. I get negative 12 is equal to negative 3t. Divide by negative 3 on each side. And that would tell me my time is equal to 4 seconds. So we're going to say 4 seconds to stop. Now this is important that we're going to use that with our displacement equation, but I have to take the antiderivative of v of t. So v of t is equal to negative 3t plus 12. The antiderivative of this would be s of t, which would be negative 3t to the 1 plus 1 over 1 plus 1 plus 12t to the 0 plus 1 over 0 plus 1 plus c. So s of t is going to equal negative 3 over 2 t squared plus 12t plus c. And then I'm going to use this 0, 0 piece to find c. So I say 0 is equal to negative 3 over 2, 0 squared plus 12 times 0 plus c. So c is equal to 0. So my equation is s of t equals negative 3 over 2 t squared plus 12t. I'm going to now plug in my time, which was 4. So I get s of 4 is equal to negative 3 over 2, 4 squared plus 12 times 4. So s of 4 is equal to, that'll be 16 times negative 3 halves. The 16 and the 2 cancel, leaving you with 8 times negative 3, which is negative 24, plus that's 48. So you end up with 24 feet. So the car travels 24 feet when it has that constant rate of 3 meters per second for the deceleration.